Hey there, everybody. The purpose of this little video is to get you some solutions to this last little randomness quiz here about pi. As we were talking about randomness in class, I stumbled upon a couple links that were talking about maybe using pi as a random number generator. We mentioned in class the idea of old random number tables. So I figured we'd analyze it a couple different ways. So let's take a look. Number one says, suppose you had these first 100 digits of pi, and you're looking at it, and you're looking for a pattern, and you're failing because there is no pattern. Not that you're failing, but there is no pattern to look for. So you're basically guessing at what number is going to come next out here. So what's the chance you get the next digit right? So since there are 10 digits, 0 through 9, if you're guessing randomly, you only got a 1 in 10 chance. So that first one's just 1 in 10 or 10%. And I said to Google the next digit, so let's just digits of pi. Let's see what we come up with here. Digits of pi, up to 1,000,000 digits. That sounds like fun. Scroll down and see the first 10,000. Okay, so here's, what's that, 10, 20, 30, 40, 50. So there's 100. Okay, so it's going to be 100, 200, 300, 400, 500, 600, 700, 800, 900. Wait, I'm counting a lot here. How far out did we actually have to go? Oh, that was only 100 digits. Whoops! So there's 100. I was going to 1,000. Sorry. There's 100, which means the next digit is that little 8 right there. So your next digit of pi would be 8. So that's the answer to the next one. Now what we're going to do is we're going to go ahead and run some analyses of occurrence of those digits. Because we said there's a 10% chance that you're going to get the next digit right. Okay, so, and we know that there's a 10% chance that any digit would show up if you're guessing randomly. So let's just take a look at the spreadsheet here. So for 10 digits, right now, and the problem, unfortunately, I can't make this, if I'm hitting F9, I don't think you're actually seeing, like I'm hitting it right now, and I'm not sure that you're actually seeing anything change. There's something weird with my little computer recorder here, and it's probably not showing you what's actually going on. So I'm going to have to just trust that you're doing this correct yourself. So if you take 10% and add and subtract the margin of error from it, clearly 10% is going to be in there. So we know it works for 10 digits. How about 100 digits? If you take 8% and add and subtract 5.88, 10%'s in there as well. If you take 9.6% and add and subtract 1.86, clearly 10% is in there. And with 100,000 digits, it goes 10.23% plus or minus 0.09. Now that one right there, it's not. It's actually, that entire interval is above, but not by much. But hopefully you've noticed as you randomized more and more and more, most of the intervals you do contain 10%. More on that in Math 244 as if you go down that route with us. But the idea is for most of these, the answer was yes. As some of you, for all of them, when I graded your work for all of them, the answer was yes. The only thing I wanted to do, one last thing, was I wanted to check to see where the runs occurred in pi. And that was just looking at the different digits. And the first question was, find the first run in pi. It was almost a stupid little trick question. I didn't mean it to be. The first run in pi is 3 because it's the number and then it changes to 1. So the first run is actually the 3. And then I had you actually count the runs. And the number of runs pi actually has is 90,000 some. The number of runs it should have, if it were truly random, is 1/5 of that, about 18,000. So that makes me kind of suspect. So I wanted to wrap up the quiz with 2 questions. Based on the 1 through 4 analyses, yeah, I think the answer is yes. It appears to be random because the digits are showing up in the correct frequency. You're getting just as many 1s as 2s, as 3s, as 4s, and so forth. The problem that I see is not in the frequency of digits, but where the digits are showing up. You're not getting enough repeating digits. As a matter of fact, one of the interesting things I Googled as I was looking at these is there's actually a neat occurrence of 6 nines, excuse me, in the first few, but the first 1,000 digits of pi. There's a place where there's 6 nines in a row. Okay, that's good. that's wonderful, and that run would actually have shown up in your Excel spreadsheet somewhere over here. Somewhere down here, you're going to see a big old blank with 5 spaces in it. Somewhere down here, we'll scroll until we see it. I would search for 9, except there are so many 9s that we're not going to be... Oh, there it is, right there. So there's all your 9s right there. So we need more of that in order for this to look like a truly random generation of digits. So that was the problem. So pi would not make a good random number generator because it's too jumpy. It's got the right occurrence of the digits, but not the right, if you will, anti-pattern of digits. So anyway, just some thoughts about the quiz. Hopefully that helped, and we'll catch you at some point. Be well.